Hi, this is Terry, and we're going to do cost behaviors in this section and then CVP analysis in the other one. So I'll say hello to you. And this is using the Garrison Transparency Masters. So we're going to jump right into number 2. Well, that jumped to 5, so let's go back up to number 2. The idea here is that we're looking at behaviors of different expenses that we have. So we want to divide them into 2 categories. The first one is variable costing. And variable costing is going to be any cost that changes in proportion to the activity. So, for example, if you were going to make no bicycles, then you would have to spend no money on those bicycles to buy a chain. But if you were going to make 100 bicycles, then you would, at $8 per chain, then you would have to spend $800. So the idea here is that as production increases, so does that cost increase, and it's at a direct or constant relationship of $8 per unit. So, and that's kind of a key concept, that the per unit stays the same. It's $8 per bicycle chain, but if we make no bicycles, we don't need any chains. If we make 100 bicycles, then we need 800 chains at $8 a bicycle. So this creates a line that goes right through our origin and has that slope of $8. If we go down here, then why does it keep jumping here? Let's get back to it here. Examples of variable costing would be the variable cost of goods sold. So that's going to reflect your direct materials, your direct labor, and your variable overhead. In addition to that, you're going to also have variable selling and administrative costs. So you'll have variable selling and variable administrative. The counterpart to this, then, is a fixed cost. And a fixed cost remains constant over different levels of activity. So, for example, if we have $50,000 is the rent on a building and we don't make any parts, we don't make any this happens to be photo sessions, so if we don't have any photo sessions, we owe $50,000 for the rent of the building because we signed the contract. If we have 1,000 photo sessions, we still have the same amount of rent. It's still going to cost us $50,000. So as production increases, the total amount here stays the same. It's constant. If we look at that concept and apply it to a per unit basis, then this is the whole concept of why you have manufacturing, is that as the fixed cost is spread over more units, then each unit has to pick up less of the expense. So again, you need to catch that this is on a per unit basis, that flat line was in total, but when we convert it to per unit, then our costs will go down as we produce more. Types of fixed costs are going to be items like depreciation, taxes, fixed salaries of our key personnel, your advertising and research, public relations, all these items. They actually call them discretionary because after a certain point in time, you might sign a 3-year advertising contract, and after 3 years, then you can change it. But depreciation and taxes and the salaries for your key personnel, those you're always going to have. Those are committed. Those aren't going to change. Moving on then, sometimes we have mixed costs. And a mixed cost is the concept of you have a variable and a fixed. So your fixed component would be right here, and your variable component would be the upper line. So here's our variable component, there's our fixed. This should make sense. Something like a commission for a salesperson. They get a base salary of $50,000 a year plus $500 for every photocopy machine that they sell. So when they get their check, they get the fixed amount, but then they also get the variable component depending upon sales. this one's using the concept of $2,500 plus 2 cents per photo developed is going to be the cost of developing those photos. There's a fixed and a variable component. And this intercept here is called alpha, which I believe is on the next slide is what we're going to look at as the equation of a line, or we can just do it right here since I have white space. It takes 2 points to determine a line. So we have the corresponding, whoops, that didn't line up, the corresponding x value and the corresponding y value, and then the corresponding x value and the corresponding y value. So you learned this in your mathematics that you had in school, that you probably learned it as y2 minus y1 equals m times x2 minus x1. That is the 2-point formula, and what we're going to use instead of m is use beta. And then if we divide both sides by x2 minus x1, x2 minus x1, then ultimately what you get is beta is the change in y over the change in x. So you learn that as rise over run. You learn that as rise over the run. And that slope becomes the variable cost per unit. So beta x would be, if x is the total number of units that you're going to sell, then beta x would be your total variable cost. With that 2-point formula, if I jiggle this, all that writing will go away, so let me make it go away. There we go. Then with that 2-point formula, we know that y equals alpha plus beta x. That's the equation of a line. So if we have solved for beta with the 2-point formula, that beta is solved, and if we substitute one of the x values like x1 and y1, we substitute in those values, now we can solve for alpha. The reason that we want to do this, you're going to see on the last slide, is that we want to take all of our expenses and convert them either to variable or fixed. And if they're variable or fixed, it's not a problem. The issue becomes is when are they a mixed cost, like shipping, those kind of issues. Well, one way that you can resolve that is to use the first method, is the scatter graph method. And the scatter graph method is that you just simply plot all those points. So you put in the $1,500 and you would say that that's 42,000. Or 1,500 units, excuse me. And the 1,900 then, would be here, and that's going to be 46,000, etc. So you plot all of these different points directly onto a graph. And if we slide down a little bit, then you'll see that what it looks like when a scatter graph is completed. So now you've got all these points. If you plot that point and just use a ruler and try and get equal number of points above and below the line, then you're going to create your alpha. And if you use one of these points that you know the x value, so y equals alpha plus beta x, you know this x value, you know the y value, and since you know the alpha value, then the only value left to solve for. Alrighty. Let's move down to the high-low analysis. The high-low analysis turns around and says, okay, let's take our two-point formula. So y2 minus y1 over x2 minus x1 equals our beta. Well, you look through here and you say, okay, what's my lowest amount of units that I shipped? So that's going to be 5,000. So we'll use 5,000 as our x value with the corresponding 65,000 for the y value. So we get this point right here. Now we learn and look at it and say, okay, 12,000. So 12,000 is my highest value, and that's 100,000. We'll squeeze that baby in there. So if we come up here and go over here, now we got our second point. And at that point, we can draw a line through those 2 points. So in other words, if you look down below here, y2 minus y1, right, the high level minus the low level, or excuse me, x2 minus x1, then this is y2 minus y1. We see the change in y over the change in x, which gives us our beta. Once we've solved for the beta, then we can just substitute into the formula either one of these numbers, that 100,000 equals alpha plus, we got 12,000 times 5. So at this point we know that alpha must equal $40,000 because the beta x is 60,000 and the total has to equal 100. All right. Problem with the high-low method is that it's only using 2 points. So if you're only using 2 points and you did a visual of the points on the graph, you'll see that that line probably is not the best fit because your value should be just a little bit lower. Your alpha or your constant should just be a little bit lower to go through those points. Okay. Another way of doing it, the scatter graph was the first way, and then the high-low was the second way. The third way is much more technical, and that's called regression analysis. So what you do is you plot each one of these points above and below this imaginary line. Then you look at the error of that line, and you take that difference and you square it. So you take the square of that error. And the idea is if you square it, then if you had a positive 2 and a negative 2 down here, you don't want them to cancel each other out. So if you square it, you get rid of any negative signs. And then when you sum the square of these errors, and that becomes the smallest possible number, then the concept is you have the best fit. And with that best fit, you now have an equation of a line. The way to do it is to put all this onto a spreadsheet. So you can take these numbers, the 4,000, 1,000, 300, 500, 10,000, 7,000, etc., and the total cost, and put them on a spreadsheet. And if you bear with me a second, I'll switch gears here and grab those numbers and throw them into a spreadsheet for you. So I'm going to copy those, pop them in here, go up to Excel, and I'm going to pop in those values. So now I can turn around and say these are the y values, these are the x values, and what I want is the slope. I want to have the alpha, and then it's always nice to have the r squared, which tells you the goodness of fit. So it's very simple that you go to your functions. In this empty cell, I want to take my function, and then I want to go to my statistical functions, and for this one I want the slope. So I go find slope, and I click on it, and then my wizard says, what's all your known y values? So I highlight those. And then it says, what's all your known x values? So I highlight those. When I get done, I click OK, and now I've got my beta, or my slope, which is $1.68 for every unit that I ship. The alpha then, same kind of concept, and that's called the intercept in statistical language. So that's your y-intercept. Again, you give it the known y values, then give it the known x, and then that built-in formula is going to make that calculation. And if we put this to currency, which is, where's my currency? Right there. I put that to currency and this one to currency. Then I see that my fixed cost is going to be $2,433.33 plus $1.68 for every one that I ship. The R square value then is RSQ. So did I go past it? Yeah, RSQ. And again, you give it the known y values and the known x. And then that turns around and tells us that we have captured all the variables. We've captured 99% of the changes in the x value is captured in that equation. So we're saying that the goodness of fit here is this is 99% accurate. Okay? Let's go back then to our normal screen. We get the same numbers here. And then this is what we're coming to, which is going to lead us into the next part of the next video is in the traditional approach. If I go back to my little magic wand here in the traditional approach, then they're all based by functions. So you have sales minus cost of goods sold, gross margin minus operating expenses is net income. What we want to do now is switch this and take our variable costs and put them in the variable section and the variable selling administrative and put them in that section. Then we want to take the fixed production and put it down here and the fixed selling administrative down below. So what we're doing is separating between the variable cost and the fixed cost, irregardless of whether or not it's a product cost or a period cost. And this will open up a whole new door, which is going to be the next video, which I'll move to now. I know these are fast and down and dirty, but what I'm trying to do is create videos that are the smallest in terms of taking up computer space. So I hope this is helpful, and again, just keep giving me feedback. All right.